All right, so the last thing I wanted to do today is an example. So we're going to use the Earth Microbiome Project metadata that you used for last week's homework, so you should be familiar with the data set. And let's go and make sure we have this in the right place. So if we go to, we're in our data folder here in this second tab. Remember, we got our first tab has got the notebook running. So in this tab, I can see that I do not have the data. So we're going to go back to GitHub, go back to data, and we need the EMP data, and we're going to make sure we view the raw format and copy that link, and then do curl-o or wget, and this will take a little minute, just a meg and a half. So we've got that now in our data folder again, so that's important because that's relative to where our current lessons folder is. So again, up one level in data, and then that's the name of the file. We're going to import this as a CSV, but we actually know it's a TSV, so we just specify sep equals tab, and we'll call that just df. So we can run df.columns to see all the columns. This has a lot of columns in the metadata, so we're going to condense this down to just these 1, 2, 3, 4, 5, 6, 7, 8 columns. And we're going to save that as itself. So now our data frame is much more compact here. We can see those 8 columns, and then we have, well, it's got 2,000 rows. So first thing we're going to do is we're going to just subsample that data to only get the rows that have temperature data. So we're going to say we want df where df.temperature digc is not NA, and then we're going to reset the index and say drop equals true, which will drop the old index and give us a new numbers, and not keep those numbers as a new column. By default, it would keep that old index column as the first column in your data, and we don't want to do that because those numbers, these numbers don't have any really intrinsic meaning. They're just numbers. So if we were to keep those, we would just have numbers corresponding to where they were before with a bunch of gaps. So we don't want that. So let's have a look. Now we have a new index, again starting from 0, and we go down. We go down to the bottom. We now have 411 rows. So the first thing I want to do is try this melt function. So we're not going to save this output. In this case, we're just going to have a look at how this works. So we can set our ID variables to sample ID, and then we're going to have 4 value variables. So what this is going to give us now is we're going to have first this first value variable, we're going to have all the sample names there. So we've got each of these is a unique sample name, and we're going to see all the values. And so this is going to give us all those values, and then if we scroll down, then we're seeing our last set of temperature. So for each, we're going to have 411 times 1, 2, 3, 4, which is 1,644 rows. So we now have quadrupled the number of rows because we have a row for each of these values. And maybe could think of a reason you'd want to have it formatted that way. We could also get, we can pivot the table by these different categories. So we can have the index as, this is very similar to group by, but it's giving us the rows will be this MPO3, which is like environment type. The columns will be biome, which is a different kind of environment category. We're going to look at the latitude, and we're going to get the mean of that latitude for each of the combinations of those different things. So if I wanted to know what is the average latitude of the aerosol samples from anthropogenic terrestrial biome, that's the average latitude, and so forth. So I can look at this and say, well, the only samples that had average latitude in the southern hemisphere was the plant surface in the marine. So these are all from Australia, actually. So that kind of use of pivot table is a way to look at an aggregate of your data in a nice way. So here we're going to there's actually a simpler way to do this that I should use, but this way works too. So we can set the index as a column. So we're going to set the we're going to have the sample ID column that's still going to be there, and then we're going to set the index as the sample ID column, and then we're going to drop that sample ID column. There is a way to just do set index, and it will change the index, and I will add that to the lesson. But regardless, what this gives us now is the index column is now our sample IDs, which has some benefits. So if we do stack now on this, it's kind of a lot going on here, but you can see the sample IDs are the top level indexes, and then the column names are the second level hierarchical indexes. And this is just a little crazy because there's a lot of data here. So again, that's a series that just has multiple levels. If we wanted all the values for one index, we can do df stack and that index. This would be analogous to doing df .loc like this. So same kind of thing, but just a different way to get to it. One difference I should point out, though, is that when we stacked, all of these get converted to the same data type, so they're all now object, whereas when we keep it as a data frame, we don't lose any of the type information. So to get a single value, again, there's different ways of getting that. We can use the stack information, or we can keep, or we can use this comma style with loc, or we can omit the loc, as we saw before. There's some flexibility there. And with unstack, different way to get the same data. We can now have those value columns that we're interested in as our first index, and then the sample ID as the second index. So again, that's a series, and again, there's different ways to get that information. And again, so we can stack these together. We can use loc, or we can omit loc, and in fact it will still work. So I just wanted to go back and let's do this a different way. So I am going to just rerun these. And then get the temperature ones. So I should be able to do df dot I think is it reindex? I think it's reset index. 1 second.